Hello everyone. Today I'm going to present about my research project Crash Free, a smart system to detect, prevent drowsiness and locate accidents. If we talk about introduction, the aim of this project is to develop a smart system which will detect drowsiness from the drivers using their facial behaviors and alert them before they get into a trouble. And it includes an accident alert to other external necessary parties such as family members, friend circle, etc. if an accident occurs. So this project will be using image processing, machine learning, and Internet of Things techniques. So these are the research questions: how to determine the drowsiness from drivers' face while driving, how to prevent or alert the vehicle drivers whenever they are drowsy, how to improve the system quality of drowsiness prediction, how to monitor whether an accident occurred or not in a particular vehicle, how to get the location and details from the driver's vehicle who met with an accident, how to notify the relevant families, friends, etc. of the driver who met with an accident. So in the literature review, we can see that in 2008, Sarada Devi and Bajaj, they introduced a system called a driver fatigue detection system based on the mouth and yawning data. They use a cascade of classifier training and mouth detection from the input photos. SVM is used to train the representation of the mouth and yawning. And in another research, the researchers proposed a method that offers a reliable and knowledgeable scheme for detecting drowsiness that combines eye closing and yawning identification approaches. So here they are using a tool called a structural similarity measure, which extract the eyes from the face area. So this SSIM is a novel approach for calculating the similarity of two pictures. And then Deng and Wu in 2019 present an MCKCF method based on deep learning and correlation filter. This approach employs CNN and multitask cascaded convolutional neural networks. And also using their method, the algorithm can follow the driver's face in real time. And again, in 2019, Pinto and other researchers, and in another paper by Hashmi and other researchers, suggest an algorithm that tracks the driver's eye and feeds them into a pre-trained CNN model that predicts the condition of the eye. Once the forecast is accurate, it will be able to determine whether the driver is drowsy or not. And Jabbar and other researchers developed a method for predicting drowsiness using MLP training models. And the authors like Tushara and PA suggest an accident detection system in which all operations are controlled by a microcontroller. Messages are delivered to a predetermined cell phone number. This system performance review revealed that accidents were falsely reported. And again, in 2014, another researchers proposed an accident detection and reporting system that uses a single sensor to identify accidents, where Raut and other researchers uses micro electromechanical system MEMS sensor to detect accidents. And if we talk about the methodology, before that, if we talk about the research gap, we can see that the researchers are considering only eye state and mouth state and all. But in this research, the research gap is to use an CNN model with SPM, and it will consider about eye state, mouth state, and the face state as well. So here, if we talk about the methodology, this research will be based on the behavioral based drowsiness detection technique, which will be analyzing the facial features like eye state and mouth state and face state and all, because this method is a non-intrusive approach comparing other approaches. So that's why this methodology is being chosen. Here, the research is going to use CNN and SVM trained model will be used to classify the images. Eye state, mouth state, and the face state will be considered separately. And in the accident detection part, an audio-based IoT device will be used to detect the accident. Two sensors such as accelerometer sensor and vibration sensor will be used. So this is the big picture. The project includes two major modules. One is drowsiness detection and alert, accident detection and notification. Now we will look into the demo. So for both modules, there is a very important part. The one is the mobile app. So each and every user who interacts with this crash fee system, they need to use this mobile app. So whoever the driver who is going to drive the vehicle, so he can have this mobile app, right? So he can register all his vehicles, available vehicles, and he can register everything. And also he can add some close circles, such as whoever in the application available, for example his friends or family members or such as, he can add that one. So once he wants to start the application, right? So this is one part. And this crash-free system contains another cloud storage, which stores all the related data, like user details and vehicle details and everything. And this backend environment of this mobile app is hosted in this Heroku platform, which is a free tier version. And when we come to this drowsiness prediction part, all the model training and drowsiness prediction and everything is done through this Colab platform, which is a free tier version of Google. So since this image processing task and everything needs a GPU to overcome with to have efficient results, so we need to have some GPU related environment. So in the physical environment, like a personal computer or something, that is not possibly not available. Therefore I have choose this environment to do this image processing related task. So here in this collab, so I have done all the image processing works, like pre-processing part and everything. And everything is stored in the Google Drive, so I can get everything from here. So I have the data sets, and I have the trained models. Everything is stored in this platform. So now I will run this video stream. So you can see now it's detecting whether what is my state actually. So we'll run this and see how it works. Okay, if I walk or do some yawning or something, right? So now we can see that, so the model is successfully predicting some elements, like if you go through this one, so you can see my eye state is so the false mean it's open, false for mouth means it's closed, false for face mean it's normal face. So you can see here it's denoting as false for eye, mouth as false, and face also false. So this one also everything is false. But if you see this one, something when the mouth is opened or something like this, so it denotes that eye is false, mouth is true, and face is also true, saying that drowsy alert. So you can see this one, drowsy alert. So in order to alert to the user who is using the system, so the thing is he needs to start driving in the very first state. So now what I will do is I will start driving and see and run this program again. So run this application again and see how it works. So I will start driving now. So all the statics will be 0 at the initial moment, right? And these readings now it's coming from the IoT platform. So I will run this video stream again. Now you can see it's predicting. So if I do some yawning or something, right, now we can see that this it is popping up an alert. So it will now pop up an alert. So this alert is denoting that it's saying that you seems drowsy. We suspect that you are not okay to perform driving. Are you okay? So now this is giving a ring to the user, and it's going to continuously alert him that he is drowsy. So what happens is he needs to continue driving, or if he is okay, he can continue the driving, or else he can stop driving and take some rest. So in order to make a successful drowsiness prediction, either the eye state should be true and the face also should be true, or else mouth should be true and the face should be true. And this will check for 2 seconds, 2 to 3 seconds continuous frames. So within that 2 to 3 seconds, if it denotes that eye or mouth face is true along with face is true, then it's going to alert the user saying that the user is drowsy. Now the second part of the crash free is accident detection module. So here accident detection module it depends on this IoT platform. So you can see that I have created a prototype in order to make this IoT platform work. So this is Arduino Uno, which is there are like 3 actual modules connected with. One is GSM GPRS field, which is available to send data, and this one is accelerometer to determine whether any other movements or something available in the vehicle. And this one is the vibration sensor to detect the vibration, high vibration from the vehicle. So I'm using 2 sensor approach here. One is accelerator and this vibration sensor. So all the data collected from this sensor will be sent to the server through this GSM GPRS module. So this accelerometer have roll and pitch values. So once if there are any changes in this accelerometer, there will be a drastic change in the values. So there will be some initial values there, and also there will be initial value for this vibration sensor as well. So it will denote some low value and the high value. So if there is a high vibration available, this is going to denote some high values. So we can run this upload this code to this Arduino, and we can see the output, how it works. So if we see this one, it's now successfully reading some values. So I can stop this one and show to you. So this is vibration, it's now 0, and this is like roll value and the pitch value of the accelerometer. So roll value and the pitch values are the values. So if this sensor is going to move this way, so the roll value is going to change. If it moves this in this direction, then the pitch value is going to change. So if there is any accident in a vehicle, we can say that there will be a high vibration available using this sensor, and with a sudden change in the environment, this part is going to move either this way or this way. So using that theory, what we can say is something suspicious happened in the vehicle. So what happens is, after a suspicious activity happened, we are prompting an alert to the driver to asking that whether he is okay or not. So we will give some time to reply, for example for 20 minutes or something. If he fails to respond with that 20 seconds, so we send notification to his close circles and friend circle. Now we can see, like, if I change this one, if I move this one, there will be value changes. There will be value changes in the value. So you can see now it's like minus 22, 23 and 28, something like that. So if I give some high vibration to this sensor, you can see that 0 is now denoting as 1, because there is a high vibration available in the sensor. if I move this way out, so then again it's going to give the drastic value change. So it's now 25, 26 something. So using this theory, we can say that the driver got some problem with his vehicle or accident or something. So now we'll see how this accident alert works along with the other closed circles. So I will start with this start driving. So you can see that now it's initially the values are 0. So now the sensor is reading these values. So once it read all the values, it's going to update this one. Now it's the values are updated. So now we will do some give some vibration and some tweaks to this IoT platform, so we can see some value changes and we can see some notifications. So I will give some vibration and I will give some position change to this accelerometer. So now you can see after this thing, so this it's prompting some alert to the driver. So this is the driver's end and this is the closed circle end. So this if a driver fails to click this button with this time period, now immediately it's going to prompt an alert to this user circle. So this one, let's say now if the user circle click this one, so he will be available to see that notification. So he can see that accidents are species warning and all the name and circle type and phone number, vehicle number, everything, it's visible. So in order to determine this suspicious activity as accident, there's a threshold value. So if the threshold values exceeded with this actual pitch and actual roll, then there will be a suspicious activity for an accident. So the closed circle can click this button, check map, and also he can view the actual accident place where it occurred from the map itself. So this is the actual process how the crash free works. So now if we talk about the evaluation plan, so I'm using two type of data set. One is a public data set, UTA real-time drowsiness data set, which is from University of Texas, and the other one is a private data set which includes 10 participants. If we consider about the evaluation of the drowsiness prediction module, in order to make a drowsiness prediction successful, or else like in order to have a successful drowsy alert, there should be a condition like eye should be closed with face also it should denote as a drowsy, and mouth should be open including face also it should be denoted as drowsy. So these are the key points that I am considering when evaluating the this module. So the number of correctly cropped eyes, mouths and faces in a given amount of data set, and the number of wrongly cropped eyes, mouths and faces in a given amount of data set, the number of correctly predicted state of eye, mouth and face, and the number of wrongly predicted state of eye, mouth and face, the number of correctly predicted state drowsiness state and the number of wrongly predicted drowsiness state, and the number of correctly given alerts and the number of wrongly given alerts respect to a drowsiness state, then the response time of the alert of a drowsiness state, and the accuracy of the models after using transfer learning. So if we consider the accident alert module, so in order to make a successful accident, in order to have a suspicious activity of an accident, so the vibration sensor also have to give a high value and the accelerometer sensor have to give high values with a drastic change. So these are the key points. One is a system result when low vibration is available from vibration sensor and average values from accelerometer. System results when a high vibration is available from vibration sensor and average values for accelerometer sensor. System results when a low vibration is available from a vibration sensor and high values from accelerometer sensor. System results when a high vibration is available from vibration sensor and high values from accelerometer sensor. and also system's reaction when detecting a suspicious activity like collision or crash. So these are the key points which will be considered in order to do evaluation for the accident alert module. Thank you.